Hi, so for this second portion, I'll be covering the internal anatomy of this dogfish. Um, so I'm starting on this slide because it gives us a good image of the three-lobed liver, which I mean, a lot of the structures are similar for our own digestive system. Like the liver produces bile, which is an emulsifier, breaks down fats. The liver itself stores fats. And it helps filter waste. Attached to the liver is the gallbladder, which stores that bile. And when food breaks down in the stomach over here, it the gallbladder sends that bile through this bile duct into the duodenum essentially, and it helps break down that food. So the stomach. So here's a good picture. So first, sharks don't chew their food. They just swallow it in chunks or whole. So it travels down the esophagus and ends up in this section of the stomach, which is muscular. And one of the key features is that it's got these rugae folds inside of it, which essentially give it more surface area so it can expand when the shark swallows something large. And basically it breaks down the food mechanically and chemically. And then down here, this J-shaped portion is the pyloric region. And it's like in humans, it's just the gateway which leads to the duodenum, the small intestine. In the small intestine, yeah, that's a good picture. It's got this spiral valve, so like unlike in us and in the frog we dissected, the sharks don't have just a mass of small intestine everywhere. It's all in this sac, and as the name implies, it's a spiral, so the food just travels down in. It does the same thing. It increases the surface area for maximal absorption, more efficient absorption. And on this small intestine, we have, I believe that is the pancreas, which, yeah, like in humans, it helps with digestion. It secretes hormones such as insulin. Um, and then this large gray structure here is the spleen. That's more of an immune system thing that helps with regulation of the immune system. And I guess since we're here, this is the rectal gland. It's a little to see here. Yeah, here, rectal gland. That that's an adaptation because sharks live in the ocean, so there's a lot of excess salt that they need to get rid of. That just helps get rid of it. Um, Another adaptation they have because they live in the ocean is urea. It it's like what we uh, dispose of in our urine, but sharks actually retain it so that they can keep an osmotic balance with the ocean's salties, essentially. I think that's it for the digestive system, although there is the colon and the cloaca. The cloaca is like a multi-purpose pore hole that works for the digestive and urinary and reproductive systems. I guess the colon would be somewhere here. It should hold the waste before it's disposed of. Yeah, so I will move on to the circulatory system. So, as I said before in the previous section, the shark has spiracles. When water's not going in through the mouth, water is going through the spiracles, and it's passing across the gills. So sharks also use countercurrent exchange. Basically, blood flows against the blood flow runs opposite of the flow of oxygenated water from the gills, so it increases the oxygen gain efficiency. And here is the heart. Sharks have a 2-chambered heart, but basically the deoxygenated blood flows from the bottom through a sinus venosus and leaves through the top in a conus arteriosus, which is apparently the precursor to the other 2 chambers of a heart. But since they have a 2-chamber heart and they use countercurrent exchange, the blood flow is kind of slow as it makes its way around the gills. And based on the fact that they have a 2-chamber heart, I assume that there's some mixing of the deoxygenated and oxygenated blood inside the heart itself. Yeah. So I think that covers it.